Hello everyone, welcome back to another video. In today's video, we will have a look at operators in Java. What are operators? Operators are special symbols, for example, plus, minus, percentile, equal to, etc., that perform operations on variables or values. For example, I have to perform addition operation. So in that case, suppose I have two different numbers, 5 and 10, and I have to perform addition on these two numbers. So what I will do? I will do 5 plus 10. Here, plus is nothing but a type of operator. And I am using plus to perform addition operation on number 5 and 10. So 5 and 10 are called operands and plus is called operator. These operators are basically used to manipulate the data efficiently. So by using this operator, we can manipulate the data. There are different types of operators in Java. For example, there are 8 different types of operators in Java. Arithmetic operator, unary operator, assignment operator, relational operator, logical operators, ternary operator, bitwise operator, and shift operator. So these are 8 different types of operator, and we will have a look at each of these operators one by one. Before moving to operators, we will have a look at few rules in Java that we should know. So we will have a look at these rules one by one. First rule is when we use a non-decimal number in Java, by default it is of int data type. So we have seen this in our previous videos as well. For example, here I am trying to print number 10 and I have not assigned this number 10 to any variable or data type. So by default, non-decimal number is always of int data type. So here 10 is of int data type. Let's have a look at another example. So here I have a byte type variable b and I'm trying to assign value 50 to it. So the literal is 50. So as I said, by default, this 50 is of int data type. So the compiler is smart enough, it will first check, okay, this int data type, I am trying to assign it to byte type variable b. So first it will check the range of byte data type. So the range of byte data type is from -128 to 127. So compiler will see, okay, this 50 can be accommodated inside this byte type v variable because it is within the range of byte type variable. So what the compiler will do, it will convert this int data type to byte data type implicitly, and we don't have to convert it manually. Although this 50 is of int data type, which is a bigger data type compared to byte, the compiler is smart enough to check the range of byte data type. It will check the range of byte data type, which is from -128 to 127, and it will see that yeah, byte can accommodate this literal value 50. So implicitly, it will convert it from int to byte data type. Now let's have a look at third example. Here again, I have a variable of int data type I, which is having a value 25. And I am trying to assign this I variable to byte type v variable. So here also I am trying to do the same thing, but here what is the catch? The catch is compiler cannot evaluate the value of this I. Here in second example, compiler can see that we are trying to assign 50 to byte type variable. So here the compiler can see the value. But in this case, we are using a variable. So compiler cannot determine what is the value of this I. So here we are trying to store int type value into byte type variable. So int is a bigger data type and byte is a smaller data type. So here data loss can occur according to compiler. It will say data loss can happen because you are trying to store value from a bigger data type to smaller data type. So here we have to do manual typecasting. So we have to write byte inside this bracket to tell compiler that we know what we are doing. You just convert it from int to byte type variable. So I hope it is clear now. In the first case, the compiler can see that we are trying to assign 50 and compiler can check the value directly into the range, like what range is allowed for byte type variable. But in second example, here we are using variable. Variable, the compiler cannot see at the compile time. It can see only at the runtime. So here we have to cast it manually. I hope it is clear. Now, what is the second rule? When we use a decimal number in Java, by default it is of double type. So yeah, whenever we are using, for example, 5.5, always it is considered to be of double type. Third, byte and short data type are always promoted to int before performing any operation. So whenever we use byte type variable or short data type variable and we are performing some operation on it, for example, byte A equal to 7, byte B equal to 6, and we are trying to perform an operation A plus B. So here the byte type variable or if we are using short type variable, they will be promoted to integer data type before performing the operation. Before performing the addition, A will be converted to int data type, B will also be converted to int data type, and then the addition will happen. See, here A and B are promoted to int before addition operation. So the compiler will take this variable, byte type variable A, convert it to int type variable. Again, it will take B and it will convert it to int type, and then addition will be performed. A plus B, 7 plus 6, that is 13. The resultant value is of integer data type, and we are trying to store this integer data type inside this byte type variable result. So again, manual casting is required. Since this is a variable, the compiler cannot check the range at the compile time. At runtime only it will be able to determine the exact value. So again, here manual casting is required. So we have to write byte inside bracket to convert this int type variable, sorry, int type literal into byte type literal. I hope it is clear. Now let's have a look at the fourth rule. If an operation has two different data type, the result will be of larger data type. What does it mean? Let's have a look at an example. So here we have a variable of int type I, which is having value 15, and another variable of long type L, which is having value 20. And we are trying to perform operation on these two variable, like addition operation. So the bigger data type here is long. So the int data type will be converted to long before performing the addition operation. Here, since L is of long type, which is larger than int type, I is upcasted to long type and the result of operation will be of long type. So the bigger data type in these two data type is long and int is the smaller data type. So int will be upcasted to long first, then the addition will happen, and then the value will be stored inside this long type result variable. So these are few rules that we should always consider before. I wanted to make sure that you know these rules before moving on to the operators topic. Now let's have a look at operators. The first operator which we are going to see is arithmetic operators. These operators are used to perform simple arithmetic operations like addition, subtraction, multiplication, division, modulus. We are directly going to see examples and how to use these operators. So let's move on to IntelliJ IDEA, and there I'll show you how to use these operators. Here I have opened my IntelliJ IDEA. We will see few examples of arithmetic operator. So I will go ahead and create a new class and I will give class name as arithmetic operators. So my class is ready. Arithmetic class is ready. I will create a main method inside it. Suppose I have a variable of byte type A. Variable name is A and it is storing value 7. And another variable of byte type B. It is having a value of 5. And I want to add this and keep its result inside a variable called result A plus B. So here we are getting an error from compiler. It is saying it is asking us to cast this expression to byte. So why it is asking us to cast it? So let's have a look at our rules. So Rule number three, byte and short data type are always promoted to int before performing any operation. So as we can see here, before doing this addition operation, this 7 will be promoted to integer data type. Similarly, 5 will be promoted to integer data type. And the addition will happen 7 plus 5, 12. The resultant value will be of integer data type. Integer is a larger data type, and we are trying to store larger data type into smaller data type, that is byte type variable. So the compiler is asking us to typecast it. So we will have to typecast it, and we have to keep this also inside bracket. So now the error is gone. If I print it, I can get the value. See, I am getting output as 12. Now let me create another variable byte and let me give name as result 2. And I want to directly add 7 plus 5, sorry, 7 plus 5 instead of using variables. But this time compiler is not giving any error. Why? I can also print this. We can print it. If I run it, it is working perfectly fine. The compiler is not giving any error. But why is that? In case of variable, it is giving me error and it is asking me to cast it. But if I am adding it directly, it is not giving me any error. The reason is here the compiler can evaluate the expression. So 7 plus 5, the compiler knows that the result is 12, and the compiler can check range of byte is from -128 to 127. So 12 is within the range. So the compiler knows that this result is within the range, of the compiler is implicitly converting int to byte type. But here, when we are using variables, the compiler cannot evaluate the value of A or B at compile time. When we will run the code, then only it will come to know the value of A and B. That's why it is asking us to cast it to byte type variable to avoid any data loss. Now, how any data loss can happen? Suppose we are having a number as 75, and here also I am having 77. So this is outside the range of byte. So the range of byte is minus 128 to 127. Now, when I run this code, see, I'm getting -104, which is not the correct answer. So data loss has occurred. So in this case, the compiler doesn't know what is the value of A and what is the value of B. So it is asking us to cast it to byte for safety reasons, because compiler at compile time cannot determine value of A and B. But suppose if I am doing addition directly, 75 plus 77. So the resultant value is around 152. So the compiler can check that value here itself. So it can check like 152 is outside the range of byte. So here itself it is giving us error, cast expression to byte. So the compiler is telling you are trying to assign a larger data type, suppose int data type to byte data type. So basically it is asking us to cast, because there can be data loss. So I hope it is clear. I will just reverse it. So one more thing I want to tell you about comments. What are comments in Java? Suppose I want to explain my code to someone, what I have done here. So I can use comments for that. Just forward slash two times and I can write addition of two numbers. So looking at this comment, anyone who is looking at my code can understand, okay, I am doing addition of two numbers. So, and compiler will ignore these line of code. So here you can type anything, you can write anything. So, and you can run your code. You will not get any compile time error, because these are comments which are used for explaining your code to someone, explaining your code to other developer, what you are doing here, what logic you are writing. That also you can write using comments, and comments can be done using this two forward slash. This is called single line comment, and you can also do multi-line comment by using forward slash star star forward slash, and inside this you can write whatever you want to Right. So this is like you can use multiple lines for writing your comments. I hope it is clear. So this part of the code will be ignored by compiler and you won't get any error. This is just for explaining your code to someone who is looking at your code, what you are doing inside this code. I hope it is clear. I will just remove this now and I will keep addition of two numbers. So this is our first example. I will just comment this instead of deleting it. I will just comment it down and we will look at another example two. Division of two number. Let's take another example. Division of two numbers. So suppose I have a variable of int type, int I equal to 10, and another variable of short type, short s equal to 2, and int result equal to I divided by s. Sorry, I divided by s. So what will be the output? So what will happen? Int I is 10. So here 10 will come at runtime. Short s is 2. So before division, this 2 will be promoted to int data type. So 10 will be int data type here. Short 2 is promoted to integer data type first, and then the operation will happen. So 10 divided by 2, 5. 5 now 5 is of integer data type. Our variable is of integer data type. 5 will be assigned to result. Now if I print it, I will get 5 as the output. 10 divided by 2 is 5. I will comment this code and we will look at another example. Multiplication of two numbers. Sorry. So I will take a byte type variable b, and value will be suppose 4, and a short type variable short s, value will be 3, and I will take byte type variable, name will be result equal to b into s. So again here, the compiler will take this byte type variable b, it will upcast it to int type. By default, b will be converted to int type before any operation. Rule number 3. According to rule number 3. Again, short will be taken, it will convert it to int data type. So 4 3s are 12. So the output will be 12. Now this 12 is of integer data type and we are trying to assign it to byte type variable result. So it is asking us to typecast it. So we will have to typecast it because at compile time, compiler cannot determine the value of b and s. So it is asking us to typecast it. So we can print it. Result will be 12. Now I will comment this down. We will have a look at another example. Example number 4. Again, I will see a division between int and long data type. Let's take an example of int and long data type. Here I have a int type variable I having value as suppose 5, and another variable of long type long L equal to 50L. So this is long type variable. Now I will create a int type result variable and I will try to store L divided by I. So here again, now the bigger variable is long. So int will be converted to long first. Rule number 4. If an operation has two different data type, result will be of larger data type. So integer is smaller data type, long is larger data type. So the compiler will take 5, it will convert it into long type variable. 50 divided by 5, 10. So the result will be long type. So we are trying to store a larger data type into smaller data type. The compiler will ask us to cast it to int type. Okay. Once the casting is done, now we can run. So we should get output as 10. Sorry, we forgot to print it. So the value is 10. Now let's have a look at another example. Let's have a look at modulus operation. So example number 5, modulus operation. Let's take int type variable I having value as 7, byte type variable B having value as 2, and int type result variable I modulus B. So if we print this, we will get output as 1 because 2 3s are 6 and remainder is 1. So the modulus operation returns the remainder, whatever the remainder is there. So 2 3s are 6, remainder will be 1. So we will get 1 as the output. Here we go. Now let's have a look at another example. I will just comment this down and let's have a look at one of the tricky question which is asked in the interviews. So I just mention tricky question. So here suppose I have a int type variable I which is having value as 7 and byte type variable B which is having value as 2, and I'm trying to divide it and store the result inside double type variable. So I divided by B. So what will be the output of result variable? So if you are thinking it is 3.5, let's see what will be the output. If we run this code, we are getting output as 3. But the correct answer is 3.5. But why we are getting 3 as the output? So let's look at our code. I variable is of int data type. B variable is of byte data type. So obviously byte will be promoted to integer data type. Now this operation 7 divided by 2. 7 is of int type. Byte has become int. Now 7 divided by 2 is 3 in int because int data type cannot store decimal values. So zero point 0.5 will be truncated and the result of this operation will be int, that is 3. I hope you are getting my point. Here the zero point 0.5 will be truncated because int cannot hold decimal number. So output of this calculation or this operation is 3 and this 3 now will be converted to double and it will be assigned to this result variable. So the output that we are getting is 3.0. So how we can get the correct answer? If you want to get the correct answer, you can simply typecast this I to double type. Now what will happen? I has become of type double. So byte now will be promoted to double type. So I and B both will be of double type. So 7.0 divided by 2.0. Now the answer will be 3.5 because we have typecasted this I to double type. So obviously double is the larger data type, and according to rule 4, if we look at the rule 4, if an operation has two different data type, result will be of larger data type. So now we have casted this integer type data to double type. Now B also will be promoted to double type. So 7 divided by 2 will be 3.5. Now this 3.5 can be assigned to a result data type which is of double type. So if I run this code, I will get output as 3.5. I hope it is clear now. So these were the few examples for arithmetic operators. Now we will have a look at unary operators in our next video. I hope you liked the video. Thank you for watching. See you.